In our previous lesson, we started talking about graphing techniques, especially related to straight lines. In this lesson, I'd like to continue talking about graphing and touch on two main points throughout the lesson. First, we'll talk about how to graph a line given its equation. And I want to do several examples of this to make sure we've got it down. We'll even talk about how to graph horizontal lines. And basically, this will be the opposite of what we were doing in the previous lesson. We'll be given the equation and we'll be asked to draw the straight line that corresponds to it. The second main topic that we'll talk about is how we can create one graph from another graph by shifting it around or flipping it around. And we'll see how the algebraic equations are changed in order to make these graphs move from one to the other. So let's start with some examples of lines whose equations are in slope-intercept form and see if we can actually draw the corresponding graphs. So if you'd like to try graphing some of these equations on your own first, just feel free to stop the video when you see the cue and start it again when you're ready. Otherwise, you can just watch and try to follow along as I work through these problems. So here's our first example. Sketch the graph of the equation y equals 5x minus 7. So we know that this is in slope-intercept form because it's of the form y equals mx plus b. And that means we can immediately spot the y-intercept. The b value, if you will, is equal to negative 7. So I know I can go plot one of the points right away. That's going to be the y-intercept at the point 0, negative 7. So I plot that point, and now we just need one more point in order to sketch the line. Remember, once you have two distinct points that the line passes through, you can simply plot those 2 points and just connect the dots. So what I want to do is now use the slope of the line to find a second point on the line. We know the slope is 5, which is the same as 5 over 1. And that's the ratio that we often call rise over run. So if we were to move over to the right 1 unit, we would have to move up 5 units. So if we start at that y-intercept that we've already plotted, 0, negative 7, move 1 unit over to the right and 5 units up, we're going to get to a second point, and that's going to be the point 1, negative 2. Once I connect those dots, it gives me exactly the sketch that I wanted. Okay, let's complete a different example that's still of this type, just to make sure we've got it down. If you'd like, try sketching this equation first before I show you how to walk through the steps. So here's the example. Sketch the graph of the equation y equals negative 1/2 x plus 7/2. Now, just like the example we just completed, we can easily and quickly see the y-intercept. That's just going to be b equals 7/2. So I can go to the y-axis and plot that y-intercept first. That's going to be at the point 0, 7/2. Done. Now, we see that the slope is negative. It's negative 1/2, or negative 1 over 2. That means for every 2 units we move to the right, we must move down 1 unit. And we have to go down because we can think of that numerator as negative 1. And if we do this, we move 2 to the right and 1 down, starting at the y-intercept of 0, 7/2, then we're going to be at the point 2, 7/2 minus 1, which is the same as the point 2, 5/2. Now I can plot that point. I already had the y-intercept plotted. I simply connect the dots, draw the line that goes through those 2 points, and that will be exactly the line that we wanted when we started this example. Now, notice that this line definitely has negative slope, and it's definitely pretty flat as well. Once I've drawn it, I can see this, and with a slope of negative 1/2, that's exactly what we would expect. So we've got some good critical thinking going here. We know that we needed a line that went down as we read from left to right because that slope was negative, and it needed to be kind of flat because the slope was pretty small. So it looks like we've drawn the right graph, and I would suggest then that we move on. Okay? All right, here's another example along these lines, and I'd like you to try this one first on your own to see how you do. So here's the example. I want you to sketch the graph of the line that's given by the equation y equals -2. All right, as you look at this problem, you might react pretty quickly with some sort of comment like, hey, wait a minute, there's no x term in that equation. Did he mess up somehow? Is there a typo? Is something wrong? The answer to all those questions is no, there's no typo, and there's nothing wrong. Everything's fine. In fact, you could even think of that equation this way. You could write it as y equals 0x minus 2, if you really wanted to, and then there would be an x term, but you would see that the slope is 0. In fact, we didn't need that 0x term there at all. The slope would have been 0 anyway. And what that means is that the line must be flat or horizontal if we want to use the fancier language. So y equals -2 is a pretty straightforward equation. It's the equation of a horizontal line with a y-intercept at -2. So if you just go to the y-axis, go down 2 units from the origin, you'll be at the point 0, -2. And through that point, you just have to draw a horizontal line. Once you've done that, you've actually sketched the graph of the horizontal line that we wanted in this example. Now, I'd like to transition a bit to sketching graphs that are still lines, but the equations are much more complicated. So let's do this together. It looks like we're doing some very different problems here. In fact, we're still drawing lines. It's just that the equations are a bit more complicated. If you're feeling pretty good about this right now, why don't you go ahead and try this one on your own, and then I'll come back in a moment and walk through the steps. So here's the example. Graph the equation y minus 6 equals 1/2 times the quantity x minus 3. Now, notice that that is the equation of a line. Do you remember what kind of form it's in? That's right, it's in point-slope form. It's very important that you actually see that equation in that way so that you can interpret the information that's being given to you in the equation. So, first things first, we look at that equation and we see that it's in point-slope form. Let's now pull out the information from the equation. First, what is the slope of this line? Well, the answer is the 1/2 that's sitting right on the right-hand side of the equation. So I know that my slope is 1/2. Now, what else do I know from the equation? What else can I pull out from it? Well, I know the coordinates of a point through which the line goes. And that point is 3, 6. Now again, I mentioned this in a previous lesson. Don't fall into the trap of saying that the point that it goes through is 6, 3. That would be the opposite of what you really want to write down. The 3 is in with the x, and the 6 is with the y. So the point that this line goes through is 3, 6. Now, it turns out with these two pieces of information, we can sketch our graph. We need to do a little bit more work, but not much. We first know that the graph goes through 3, 6. So we could just go right to some graph paper right now, to a set of axes, and plot 3, 6. We'd be done with our first step. After that, we know that the slope, which we often call the rise over run, is 1/2. So for every 1 unit that I go up, I need to move over 2 units to the right. So another point on the line is 5, 7. Where do the 5 and 7 come from? Well, 3 plus 2 is 5, and 6 plus 1 is 7. I plot that point now, 5, 7, and I now have 2 points plotted. I simply connect the dots, and I'm done. Now, notice something about the y-intercept of the graph. Once you've drawn the graph, it looks like the y-intercept is 4.5 or so. You could have determined that using that point-slope form of the equation if you wanted to go ahead and rewrite that equation. You should also notice that the x-intercept appears to occur somewhere around -9, 0. Again, you could check this as well by plugging that information into the equation, if you wanted. And lastly, we should really ask, does the graph make sense? Well, it definitely goes through the point 3, 6. We knew that it needed to do that. And it definitely has positive but smallish slope. The graph is definitely going up, not down, as we look at it and as we read it from left to right, but it's definitely not very steep. If the slope had been something like 20 instead of just 1/2, then we would have seen a line that would have much steeper slope, and the graph would have been much sharper as we read it from left to right. In this case, the graph is pretty flat, and so we're happy with our picture. Now, let's keep talking about graphs of lines. Let's look at another example of this type. And again, I ask you, can you graph this one before I actually walk through the steps? Here we go. The example is this. Graph the line which corresponds to the equation y minus 4 equals the quantity x plus 2 all multiplied by 7. Or you might say it this way, y minus 4 equals 7 times x plus 2. Again, I see immediately that this is in point slope form. It's extremely important that we see that, because if you just see the equation and you don't recognize it as point slope form of the equation of a line, then you won't know what the 4 is doing, or what the 7 is doing, or what the 2 is doing. So once we have that, let's now interpret some information that the equation is basically trying to give us. First, the slope. Well, that's sticking out in front on the right-hand side of the equation. That's m equals 7. So that's positive, and 7 is relatively large. It's certainly a lot larger than 1/2. So I'm going to expect that the line I'm about to draw will go up as I read from left to right, and it's also going to be much steeper. It's going to go up much quicker than the line that we just drew in that previous example. So that's one thing we need to see. That's one bit of interpretation. Now, what else do I know? Well, I know a point that the line goes through. Now, if you said that it was 2, 4, you'd be close to the right answer, but that's actually not exactly right. And if you use 2, 4 as the point that the line goes through, then your graph is going to be wrong. So why isn't the line going through the point 2, 4? Well, it's because of that plus sign in the original equation. Remember, the point slope form of the equation of a line is y minus y1 equals m times x minus x1. It's not y minus y1 equals m times x plus x1. You see the difference of the signs there inside the parentheses? The correct equation has a minus sign in it. Our equation has a plus sign in it. So what do? Are we just sort of stuck? Do we not know what to do? Nah, we're not stuck. We know exactly what to do. We just have to rewrite the equation that we started with just a bit so that it looks right in the point slope form of the equation of a line. We started with y minus 4 equals 7 times the quantity x plus 2. I can rewrite that just slightly in the following way. Y minus 4 equals 7 times the quantity x minus negative 2. Notice the minus with the negative 2 would really be written as a plus 2 when we were normally writing this equation down. But I'm going to rewrite it this way with an x minus a negative 2 so that I really have the point slope form of the equation of a line as it's usually written. And now that I've written my equation this way, I can see that the point that the line goes through isn't 2, 4, it's actually negative 2, 4. And that's a very important difference. That's going to change where I draw this graph once I get the correct point on the page. So now I can sketch my graph. I know two very important things. I know that the line goes through the point negative 2, 4, and I also know that it has slope 7. So I need to figure out another point that the line goes through. Starting at negative 2, 4, I could add 1 to the negative 2 and add 7 to the 4. Remember, The slope is 7, so it's 7 over 1. That's 7 in the y direction and 1 in the x direction. So I'm going to add 7 to the 4, and I'm going to add 1 to the negative 2. And when I do that, I know a second point that the line goes through. It's going to go through negative 1, which is coming from negative 2 plus 1, comma 11, and the 11 is coming from 4 plus 7. So it's very important that we interpret that slope correctly. That 7 is the same as 7 over 1, 7 for the rise, 1 for the run, and that means the 7 gets added to the y and the 1 gets added to the x. So I've got a line that goes through 2 points, negative 2 comma 4 and negative 1 comma 11. I plot those 2 points on my coordinates, on my coordinate axes, and once I've done that, I can connect those two and I'm done. And again, if you look at that line, it should have been pretty steep reading from left to right, and it should go up because my slope was positive 7. Now, if you've been following along pretty well, you should have a pretty good idea of what the graph of a straight line looks like once you've been given the equation. We've spent several minutes now working through those kinds of problems. Here's the equation, draw the graph. Here's another equation, draw another graph. Right now, I think it's time to quiz yourself and see how you do. So here's what I'd like to try. Let's match the following equations to their graphs. So we're going to look at 4 equations now. All 4 of these are equations of lines, and I want you to match their graphs to the equations. So here are the 4 equations. X equals 3, y equals x minus 3, y equals 3, and y equals negative x plus 3. Now, let's walk through and see where those 4 equations match up to the 4 graphs that you see. Okay, now let's walk through those one at a time. First of all, x equals 3. What kind of a line do we get when we just have x equals a number? Well, in that case, you're actually going to have a vertical line, because if you think about it, all of the points that we go through have to have x equal to 3. So you might be at 3, 0, or 3, 1, or 3, 2. All of those points line up one above the other. And if you connect those dots, you're going to have a vertical line. So the first equation, x equals 3, must match up with a vertical line that you see on your screen going through the point 3, 0, for example. Now, what about y equals x minus 3? Okay, that is in slope-intercept form. You might not see the slope there, but it's really there. It's hiding a bit. It's right in front of the x. It's a 1. Y equals x minus 3 is the same as y equals 1x minus 3. Now, if you think about it for a moment, the y-intercept must be at negative 3, so I'm on the y-axis 3 units below the origin, and the slope is positive 1, which means the graph must be going in the positive direction as we read from left to right. Can you match that one up with one of the graphs? Great. Now the third equation, y equals 3. We've already seen an example of y equals a number. You remember what kind of equation that is? It's a horizontal line. So the graph of y equals 3 must be the horizontal line that's going through the y-intercept at 3. Well, lastly, whatever's left must be the right graph, but let's talk through it really quickly. The last equation was y equals negative x plus 3. Negative x is the same as negative 1x. So this is a line whose slope-intercept form we already have. The slope is negative 1, and the y-intercept is at plus 3. So its y-intercept must be above the origin, 3 units above, and the slope is now negative. So the line must be going downwards as we read it from left to right. And that should be the last graph that you had left. Now, if you got those right, fabulous. If not, you might want to do a little bit of review on graphing these lines that we've done in this lesson before you go on. But keep working at it. It'll come. It's a very important task to learn how to draw the graphs of straight lines given their equations. Okay, we've spent a good bit of time graphing lines. Now I'd like to switch to the other goal of this lesson, which is to talk about different ways that you can take a graph and manipulate it with shifting either left or right or up or down, or even flipping it around in order to get a new graph. So let me start with a graph that we're going to see a lot in this course. It's the graph of y equals x squared. Now we're going to talk a lot about where this graph comes from in future lessons. But for now, just trust me, this really is the graph of the equation y equals x squared. Sort of a nice U shape going right through the origin. Now, I'd like to use that graph to demonstrate some of the ways that we can move it and show how the algebraic equations change as you do that moving. So for example, let's say I wanted to move the graph of y equals x squared over 3 units to the right. Then I would get the graph that you see here. But what does the equation then look like once you've moved the graph? Obviously, the equation can no longer be y equals x squared because that graph went through the origin. This graph doesn't. It turns out that the new equation for this new graph is y equals the quantity x minus 3 whole thing squared. And all we've done is changed from an x being squared to an x minus 3 being squared. Okay, let's try something very similar. What would the graph of y equals x plus 4 squared look like? Well, if you start again with the graph of y equals x squared, the one we started with a few moments ago, and now move it 4 units to the left, then you would have the graph of y equals x plus 4 whole thing squared. And this leads us to the first of our graph changing rules, if you will. If you take the graph of a certain equation and change all the x's to x minus a number, you pick the number, then it turns out that you move the whole graph over that many units. If the number that you subtract, let's say x minus a, is positive, if that a is positive, then you move to the right. If the value of a is negative, then you move to the left. It's that simple. And that's how you go from something like x squared to x minus 3 squared or x plus 4 squared. Okay, that's how we move left to right when we're drawing our graphs. What next? Well, let me go back to y equals x squared again. This time I'd really like to move it up 2 units. What would I have to do to the equation to be able to get the graph to move up 2 units? Well, it turns out that that new equation would be y equals x squared plus 2. Remember, I wanted to go up 2 units. Notice that the x term was not affected this time. I left the x squared part alone. I actually added 2 to the whole right-hand side, if you want to think of it that way. So if I want to move a graph up by b units, let's say, we just have to add the amount b to the whole right side of the equation. We don't mess with the x so much. We just add that value of b to the right-hand side. And if b was a negative number, when I add that part, then the graph would actually go down instead. So for example, if I started with the graph of x squared and wanted to shift it down 3 units, the new equation would be y equals x squared minus 3. Now, as I move on to other rules for changing these graphs, let me also talk about how you could flip the graph of an equation, not just move it from side to side. We know how to move to the right and to the left by adding or subtracting an amount just to the x. But I also know how to actually flip over the x-axis. And it turns out that it's not that hard to alter the function in order to do that. If you multiply the whole right-hand side of an equation by -1, then it turns out that the graph that you started with will actually flip over the x-axis. So, for example, if I start with y equals x squared, which has this nice parabola going through the origin, nice U shape pointing up, and I switch that to y equals negative x squared, so I multiplied that right-hand side by -1, then it turns out that the graph switches from the nice U shape going up to, again, the same U shape, but now going down. Notice that it's still going through the origin. It just looks like it's been taken and flipped over the x-axis. And so flipping that way actually turns out to be done by multiplying the equation that you started with by -1. Now you have to multiply the whole right-hand side of the equation by -1 in order to flip that graph. But you can do this now to a wide variety of graphs and their equations simply by multiplying by -1. So, for example, earlier we talked about the graph of the line whose equation was y equals 5x minus 7. It goes through -7 on the y-axis, and it has a slope of 5, so it's somewhat positive and steep. If I wanted to then look at the graph of y equals negative the quantity 5x minus 7, which of course is the same as y equals negative 5x plus 7, then all I have to do is take the line we started with a moment ago and flip it across the x-axis. And immediately I would have the graph of y equals negative 5x plus 7, because that's the same as y equals the negative of the quantity 5x minus 7. Now, notice that the x-intercept of this line is the same as the x-intercept of the other line that we started with. It's just that the lines have been flipped around the x-axis. That's all we've done. We went from the line that had positive 5 as its slope and had a certain x-intercept, and we kept that intercept there on the x-axis and flipped the whole line across. So the y-intercept changed, but the x-intercept actually stayed the same. Now, next time I want to spend a little more time talking about what a function is. It's very important as we walk through this course to understand what a function is and to talk about several vocabulary terms that are related to functions. This would include things like what a domain of a function is, what the range of a function is. In fact, we don't even know yet what a function is. You and I will need to talk about that. And we'll want to understand which equations that we can write down are going to be functions. Turns out that all of the equations that you and I have walked through together in all of our lessons have been functions. It's just that I've been hiding that word from you all this time. But we want to talk about what a function really is, and what its domain is, and what its range is. And functions are going to play a very important role throughout the rest of this course. Believe it or not, functions play a very important role in things like pre-calculus and even calculus. So I really want to make sure that we've nailed down this concept of a function before we work into the rest of our course. I'm really looking forward to talking about those with you in the next lesson.